The last topic we're going to look at in this chapter is the motion of the planets. There are 5 planets that are bright enough to be seen without a telescope. We divide them up into the inferior and superior planets. The inferior planets are Mercury and Venus. They aren't inferior because of their size, brightness, or sense of personal security. We call them inferior because they always stay close to the sun in the sky. The superior planets are Mars, Jupiter, and Saturn. They can be close to or far from the sun in the sky. However, both sets always stay close to the ecliptic, the path the sun appears to take through the sky over the year. Just like the sun and the moon, the planets all rise in the east and set in the west every day, and that, of course, is caused by the Earth's daily spin. However, if you watch for several weeks, you notice that the planets also drift slowly against the background stars. Usually, they drift towards the east, just like the sun and the moon. We call this motion prograde, and it causes a planet to rise slightly earlier each night. However, every 1 to 2 years, a planet will appear to do something very strange. It'll start going backwards against the stars. This is called retrograde motion. This retrograde motion can last from a few weeks to a few months, after which the planet turns around and starts going back prograde again. All of the planets do this at some point, but it's not always the same time of year. For the superior planets, it does happen whenever the planet is directly opposite the sun from our point of view here on Earth. So, what causes a planet to appear to move backwards? For almost 2,000 years, explaining this motion was one of the biggest challenges in science. Most solutions were based on the then common sense idea that things in the sky were spinning around the Earth. A few people suggested otherwise, but there is no sign that anybody took them seriously. In the 16th century, a Polish monk named Nicholas Copernicus published a book suggesting that the problem could be better explained if we assumed that the Earth was a planet moving around the sun rather than the center with everything moving around it. The Copernican model had all of the planets orbiting around the sun. The closer planets moved faster than the ones farther away. What Copernicus argued was that retrograde motion was an illusion caused by the Earth's motion. When we pass one of the outer planets, they appear to move backwards because we're moving faster than they do. Similarly, when one of the inner planets passes us, the same thing happens. You can get the same effect when you pass another car on the freeway. Don't try this when you're driving, but if you watch a particular point on another car as you pass it, you'll have the illusion that it's moving backwards against the background scenery. Of course it's not, it just looks that way because you're going faster than it is. As we get farther from another planet, the planet's own motion starts to dominate what we see again, and it returns to prograde motion. As I said, Copernicus wasn't the first one to suggest this, but he did back the idea up with detailed calculations of planetary positions. He also had the good fortune to have published this less than 50 years before the invention of the telescope. The people who first pointed telescopes at the sky and confirmed this motion had copies of Copernicus's book to help them make sense of what they were seeing. However, the confirmation that the Earth was a planet orbiting around the sun forced a whole new set of questions about the nature of motion and how we experience it. It wasn't until the end of the 17th century before these questions were answered. We'll have a look at these questions when we deal with forces and motion.